Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 7, Coordinate Systems in 2- and 3-Dimensional Forms. Section 62, Condition that a point be on a line. Suppose that, referred to a system of a point and line coordinates described above, a point P has coordinates AB, and a line L has coordinates MN. The condition that P be on L is now readily obtainable. Let us suppose first that none of the coordinates A, B, M, N are 0. We may proceed in either one of two dual ways. We adopt one of these. We know from the results of the preceding section that the line MN meets the x-axis in a point whose x-coordinate is -1 divided by m, and meets the y-axis in a point whose y-coordinate is -1 divided by n, figure 81. Also, by definition, the line joining P equal to AB to U meets the x-axis in a point whose x-coordinate is A, and the line joining P to V meets the y-axis in a point whose y-coordinate is B. If P is on a line L, we clearly have the following perspectivity. Relation 1 -1 divided by m, O, A, infinity x is perspective with center P to -1 divided by n, O, infinity y, B. Hence we have relation 2, the net of rationality, r of -1 over m, 0, A, infinity x, is equal to r of -1 over n, O, infinity y, B, which, when expanded by Theorem 13 of Chapter 6, gives us the desired condition. Relation 3, MA plus NB plus 1 equal to 0. This condition has been shown to be necessary. It is also sufficient, for if it is satisfied, relation 2 must hold, and hence would allow Theorem 13, Corollary 5, Chapter 6. -1 over m, O, A, infinity x is projective with -1 over n, O, infinity y, B. But since this projectivity has the self-corresponding element O, it is a perspectivity which leads to relation 1, but this implies that P is on L. If now A equal to 0, B not equal to 0, we have at once B equal to -1 divided by n, and if B is equal to 0, A not equal to 0, we have likewise A equal to -1 over m, for the condition that P be on L. But each of these relations is equivalent to relation 3 when A equals 0 and B equals 0 respectively. The combination A equals 0, B equals 0 gives the origin, which is never on a line MN, where m is not equal to infinity is not equal to n. It follows in the same way directly from the condition that relation 3 gives the desired condition if we have either m equals 0 or n equals 0. The condition 3 is then valid for all cases, and we have Theorem 1. The necessary and sufficient condition that a point P equal to AB be on a line L equal to MN is that the relation MA plus NB plus 1 equals 0 be satisfied. Definition: the equation which is satisfied by the coordinates of all points on a given line and no others is called the point equation of the line. Definition: the equation which is satisfied by the coordinates of all the lines on a given point and no others is called the line equation of the point. Corollary 1. The point equation of the line MN is mx plus ny plus 1 equals 0. Corollary 1 prime. The line equation of the point AB is AU plus BV plus 1 equal to 0. Exercise. Derive the condition of Theorem 1 by dualizing the proof given.
Projective Geometry, Volume 1. This book was written by Oswald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.